Good morning, still morning, still morning. Seattle Prep Calculus. BC, welcome. I've recorded this video to go through to just give hints on all the problems on that first free response problem that has, it goes down to the letter P, whatever that is. Let's see, 13, 14, 15, 16 parts. So I just have hints. I'm going to go through a video. It's just going to show the hints. It's not going to show the answers. I'll send out an answers video later, but I thought this would be a better way of doing things. So there we go. Whoop, that's not the right one. Sorry. That's the right one. There we go. And so here we go with the hints. So first one, we kind of talked about this idea of, well, whatever I'm given the derivative, how do I find the y value? The y value is just, well, whatever, you need to have some kind of y value that you're given because of the plus c. If you weren't given some initial value, you wouldn't have a way to figure out a place to start from on this one. So we can say, oh, okay, so they gave us what f of 2 was. So start from 2 and then do the integral from 2 to -3 of the derivative. And so that's just going to be a question of doing the integral of this. That's going to be finding the area. The one thing to watch out for is, remember, you're working backwards, so everything's going to count opposite. You see, these are quick ones. On the second one, again, it's I talked about this one in class. You'd break it up into two integrals. And again, you're going to be doing the same thing where you're integrating this function that's up here, so you'll be working with area there. This one also was talked about. So it's the antiderivative of f, of f double prime, which is just f prime, as long as you've got the chain rule taken care of for this. So I had to do a Lindstrom effect and put a -3 on the inside to take care of this, and then I put a -1/3 on the outside. And this one we also talked about that I know the integral from -1 to 9 of this thing is -3, so that tells me -1 to 9 is -6. And I want to find 9 to 6. Anytime I just see these integrals where I see multiple integrals with different bounds, but they overlap, there's some connection, I go, oh, okay, I've seen these things before. And so the integral from -1 to 9 plus the integral from 9 to 6 is the integral from -1 to 6, right? And so -1 to 9, they gave us that. So that's -6. And this is what we're trying to find, right? And so the integral from -1 to 6, I can just go up and use areas to figure out what the integral from -1 to 6 is. Okay, now we're getting to some stuff that we haven't, that wasn't asked in class. Find the critical points, and then for each x value, you determine if it's a relative min, relative maximum, or neither. That sounds very much a first derivative test-ish here. And so for a critical number, a critical point for a function is when the derivative equals 0 or is undefined. But the derivative is always defined in this one, so that's not an issue, the undefined part. And so this is the derivative right here of the thing we're talking about. And so when is this thing 0 or undefined? That's when x equals -1 or x equals 2. And then you'd want to apply the first derivative test, I think. And I'll give you a hint. One should be a max and one should be a min. Then find the maximum value on a closed interval. See, that was looking at the critical numbers and deciding, are they maxes or min, local maxes or mins. But now find the absolute maximum value on a closed interval. So you have to look at the endpoints. Many of these you can figure out just by doing area. The same idea. You're going to start from here, and here you're at -3, and so you want to find like f of -1, where you're just going to have to work backwards with that area. And f of -3, you're going to work all the way back to here. But remember, because you're working backwards, all the areas are going to be opposite. And then f of 2, well, that's just -3. I got that one. And f of 6, I'll find the amount there. One thing you could do on this one is you could kind of make an argument here. You could say, well, I start at this value here, and then I gain all this area from afterwards. And so pretty clearly, this is going to be where the absolute maximum is, because I'm going to go down this, which means, wait, hold on a second. But, so like if I started at some initial value, I went up a little bit, I went down, and then I went way up a bunch. And because this area is more than this area, the maximum value is going to be at the end of this, because I'll have accumulated a bunch when I went from 2 to 6. That's an argument. You still have to find out what the maximum value is. And I'm just reminding you that you need to, this is the typical thing, is just finding all the f's. Kind of your choice on that, on how you want to do it. You could make an argument why it has to be 6 and then just find 6, or you can just find them all and then take the biggest one. But 6 will be the biggest one. Decreasing concave down. F prime of x is less than 0. Concave down. F double prime of x is less than 0. But just remember that you're looking at f prime. You're not looking at the original function. These are all really good questions. I have no objection to any of these. I kind of, I don't want to say bad mouth, but I, had some concerns about this guy's test writing. But his questions are good. Order the values of those from least to greatest. So f of 2 they gave you. Yay! If they'd done the same thing for like 1 or something, then you could work it out by doing the integral, And so say, well, at 2 I'm at -3, and then work out some other value. F of 2 is -3. F prime of 2 is just going to be, look at the y values up there, because that's f prime up. Yeah, okay, making sure that I'm on screen here. That f prime is up there, so that should do the job. And then finally, I'm just gonna. I'm gonna move my picture down here. There we go. And then f double prime will be the slope of that function that's above, because that thing is f prime above. So what's the slope of that? Should be able to do that, and you should be able to find the slope because it's linear through that area. This one, find the points of inflection. So points of inflection, f double prime changes signs, right? And so, but this is f prime here. So f double prime of x is the slope of the above graph. So when does the slope change signs up above? It doesn't have to be defined. The second derivative doesn't have to be defined at the points of inflection. It can be undefined. F double prime can be undefined. It's just before it was one thing, after it was something else. And there needs to be an actual point there. But they said that the original function is continuous. So there's a point there, and it has a derivative because it's differentiable. And you can see everywhere there is a derivative for every single x value. It's just at some values, you don't have second derivatives because the derivative of the derivative is undefined. But that doesn't stop things from being inflection points. Might have given away the answer there. Average value, there's the formula, and so it's just going to be, so that's definitely one you want to have like buried in your brain, the average value of a function. And they're saying, what's the average value? Oh, I just said of f of x, so that was just giving the general formula there. So in this case, it's the average value of f prime of x. F prime of x. So that's 1 over 6 minus -3, 1 over 9. And then you have to integrate that thing up above from -3 to 6. But that shouldn't be a problem with areas. Yeah. And that's the average value of the function. Now this is talking about the average rate of change, and that's the big thing. Average value of a function, mean value theorem for integrals. Average rate of change, that's mean value theorem. And so they said that's equal to 2/5, just going to this. That's because that's the slope of that line from 1 to 6. The slope is 2/5. So the average rate of change is just the slope from beginning to end. And explain why it doesn't contradict the mean value theorem, because mean value theorem said between 2 points, whatever the average slope is between them, you're going to have some moment in between where it achieves that slope. There has to be at least one moment. There could be more than one. But they're saying there isn't a place in between those two where the slope is 2/5. Why is that? And it's just an understanding what the conditions were to apply the mean value theorem. Great questions. Awesome questions. We talked a little bit about the Euler's method 1. I just wrote down the stuff that we talked about. So for 2, -3, I plugged in the points. I plugged in -3 for y and 2 for x. And f prime of 1 is just the y value here, which is -2. And so when you work it out, you get that the slope is 3. And then now we're going f of 1. F of 1 is f of 2 plus how far did I go over times the slope. And you know what the slope was, and you know what f of 2 was, and so you can work those out so that when x equals 1, you come up with an approximation for what y is. Sorry, I didn't mean to move my screen there. There we go. Okay. Next one, the Maclaurin one, I think I kind of talked about. If I have time, I'll come back to it to write some stuff down. This one I thought was tricky, and I was like, what are you doing on that one? Because I was like, okay, there's two functions there. There's no chain rule thing I can do, but so it looks like parts, right? But there's no way to improve sine by either taking its derivative or its antiderivative. That doesn't help you. There is a trick that was in the book. We didn't have problems like this because they never show up, where you do it twice to get back to the original function, and then you can kind of combine terms and group things, and you can make progress that way. But that wasn't something we ran into, and so I was like, oh man, is this guy throwing that on there? I was getting ready to send an email. But then I thought, well, what about the other function, f prime? So f prime is, do I have another picture? Yeah, there it is. F prime is this thing right here. I have to integrate that function. Is that function easier to integrate as what it is, or instead as I just thought of another way you could have done this, or instead as its derivative? And then you look at it and you go, oh man, I'd love to instead work with the derivative of this thing, because the derivative of this thing is constant. And so that's because, so the derivative, f double prime is just 2. And so, right, that's just the slope of this thing is f double prime, and the slope of that section is just 2. So you want to make u equal to f prime of x, so that du is f double prime of x. And so dv will be sine x dx, which makes v equal to negative cosine x. F double prime x dx. There we go. Should make sure the dx is there. And so now, if you do integration by parts, it's a piece of cake. So tricky one there. The other thing I just realized afterwards is that you could have, from 1 to 3, you could find the equation of that line, and you could have put that in, and that would have been fine, and that would have worked. And it probably in the end ends up to the same thing, because you would integration by parts, you'd still take the derivative of that, and you'd still get 2. So yeah. I'm just thinking, is there another way? No, let's leave it at that. Okay. For this one, it's arc length, and there's the formula for arc length with the numbers thrown in here. And we want the arc length of f. You have to watch out on this, because there's f and there's f prime and stuff, so you have to be careful. So it's that thing squared from -2 to 1. I was like, how am I going to do that? And all I have to do is write the expression. I don't have to work it out. But how am I going to write that expression there? And then I was like, oh, wait, from -2 to 1. This is where the other time I had that idea of, we actually have the equation for that. So you could figure out the equation of that line pretty easy, and you could put that in for f prime. F prime of x is, well, negative x minus 1, right? And so you could just put that in squared and then walk away, because remember, you don't have to work it out. Finally, this last one is doing this with a Riemann sum is an over or underestimate. You don't have to actually do it. You just have to say is an over or underestimate. Well, if you think about it, if the function is increasing, then a left Riemann sum is going to be an underestimate, because you're always going to be using the smallest y value for each region. But if it's decreasing, then it's going to be an overestimate. Make sense? All we have to do is find out, is this thing increasing or decreasing? And so the question now becomes, is p of x increasing or decreasing? How do you know if you're increasing? That the question is p prime of x greater than or less than or greater than 0? And so you just have to find out, is it positive or negative over this interval from 2 to 6. I'll let you do that now. So that's pretty much the end of the time. Sorry if you had to scroll through, kind of wait through a bunch of other ones that you didn't need to know to get to the end. Again, I'll send out the official answers with all the information at the end of the day, so you can check your work and see how you did. But I hope that helps you get started on some of the problems. And we'll also include answers for BC2 afterwards, because, yeah, this is a lot of stuff. And, man, this is reviewing a ton of great stuff for us. I think that's it. Friday is asynchronous. But, of course, I'm always up during these times. So if you have any questions on homework or something during our meeting time, you can probably find me. Just send me a message, and we can meet up on Teams, and I can answer any questions. Okay, that's it. Bye.